This is basically the introductory course where you can understand about the acceleration due to gravity. Number 2 is the variation of the acceleration. Number 3 is the escape velocity. Number 4 is the orbital velocity. Number 5 is the gravitational potential. Then we'll learn about the time period of a satellite. Okay, and then we'll go for the height of satellite and how to find the equation of the height of satellite. Then definitely we'll go for the binding energy. We are not talking about the molecular binding energy, but also we'll go for the expression of the binding energy in great scale. All right, so in larger scale, I mean, and then we'll move to the Kepler's law. All right, and after then we'll go for the variation of the G. With in terms of the rotation of the earth. Okay, so this is the basically contents of this particular chapter. So I'm not going to go for for the very basic idea of the gravity. You all know, you all familiar with the universal law of gravity and the law and what its law says. Okay, so let me come back here. What gravity means? This is the very first question appear in your mind. So this is the sun, right? So let me quickly draw everything for you. Clearly we know they have different masses, right? We know that the earth has a very less amount of mass, very little mass in comparable to the sun, right? So for example, if we talk about, if we know this is the formula, we know everything, that is if the mass of the sun, let's say for example the mass of the sun is capital M, we are taking, okay, and the mass of the earth, let's say small m, that the force is equal to G n m by r square, and there must be a vector. Okay, so there is a unit vector, as we know that this force is a vector quantity, right? So this is the very basic idea of the gravitation. Now if you can play with the that capital mass or the small mass and the distance between them, definitely going to get different results. But if you look very closely, this force is a vector quantity as well as the unit vector r cap. The left hand side of the equation is a vector quantity, and none of these quantities are vectors, so that's why we need to introduce one r cap, which is basically important in this formula. Okay, so let me come back. Now, the very next question is what would be the dimension of capital G? This is very important question. So if you want to find the dimension of capital G, this is very easy, because in the left hand side you can see that the force, and we all know the dimension of the force. This is basically mLT to the power minus 2. And if we multiply with the r square, because we want to find this G, right? So r square by m1 m2, and we know that m1 m2 they have the dimension of the capital M. So basically we will end up with m inverse L cube t to the power minus 2. I believe you all familiar with the dimension analysis and this m, L and t, right? So this is basically the dimension of the gravitational constant, universal gravitational constant. But if I ask you what is the basically unit of the universal gravitational constant, you will say that this m inverse, that means there must be the mass inverse unit, there must be some length cube unit, and there must be some time inverse square unit. So if you do that, then you will be able to get different unit. But the actual unit for the universal law of gravitation is this Newton meter square per kg to the power minus 2, where Newton is the unit of force, and r square, if you look at this formula, so F is the unit of Newton, and the r square is basically representing the m square, and then m and m, this is basically kg to the power minus 2. So this is the formula for the universal law of gravitation, right? But if you can write in unit in terms of dimension, for example here if you look at, then F equal to ma, and mass, and that is a mass into acceleration. We know that acceleration is a unit is mass per second inverse, so you can easily write that m square per second to the power minus 2. Right, so this is a very important idea of the unit and the dimension for gravitational constant. So now we'll move on to the vector form of the universal law of gravity.